Okay, let's say you've got a graph like this. So I've got y is equal to sine x and y is equal to 1/2 of x minus pi. That's this straight line. The sine x is that curve right there. And I want to do some integrals. Like I want to do, for instance, let's say I want to do find the area of something. Well, the area is just equal to the integral of 1 times dA. And that should be done over the entire area, like that. Okay. I could also do a different integral. I could do, for instance, let's just copy this and paste it here. I could also find the moment of that area about, say, the x-axis. That's the x-axis here. Um, and I need to figure out how to do that. So to start doing this, I need to actually write what this dA is here. So I'm going to come back here and I'm going to make a little rectangle, some arbitrary location here, like that. So that's my dA. Okay, it's dx wide and dy tall. And if I want to do the area again, I just do sum all of these guys all over the entire area. That's what that means right there. If I want to take the moment about the x-axis, that's this distance here, which is just some arbitrary distance y times dA. So that's the area times the moment arm to the x-axis, right? I could also do the moment about the y-axis. That would be the integral of x dA. Again, here's my dA, and the moment about the y-axis is this distance, some arbitrary distance x. We use those moments of area in the centroid formulas. So for instance, x bar is equal to the moment. If I'm taking x bar, that means I want to find out where in the x direction the centroid of this shape is, right? So I'm gonna, if I want to find x bar, then I'm integrating, I'm doing the moment about the y-axis, which is the x distance, right? And it's going to be this right here divided by this right here. So that's how you find the centroid in the x direction. So I'm taking, whoops, this is going to be the integral of x dA. And I'm taking moments about the y-axis, which is the distance in the x direction. So it'll be the moment about the y-axis, which is x dA, divided by just dA. And I can do the same thing for y bar here. Y bar now would be equal to the integral of y dA. In other words, I want to find how far the centroid is from the x-axis in the y direction, right? So that's the moment of this area about the x-axis, which is the distance y, right? So here's my little dA. It's a distance y from the x-axis. So if I'm doing y bar, it's the moment of area divided by the area. But I could also do something similar to this called I of x, which is just the second moment of area, and we define that as the integral of y squared dA. And finally, the last thing we learned about in class is the moment about the y-axis, which is the integral of x squared dA, like that. So there's my possible integrals that I could do. Again, find the area here, or find the centroid in the x direction, or the centroid in the y direction, or the moments of inertia about the two axes. Those are all the things we can talked about in class. Okay. Now I want to show you how to do this with double integration. That's why I've done this teeny little thing right here. And I'm going to call this distance here dx, and this distance here I'm going to call dy, and together those make up dA, dx, dy. And you can interchange these. Like for instance, I can do dy dx instead of dx dy. This is just multiplication, and multiplication is commutative, so you can switch it. It doesn't really matter. Okay, so if I'm going to do double integration here, what I want to do is I want to take this guy and either integrate first in the x direction without changing y, or integrate in the y direction without changing x. Either way. But it turns out that I have here y in terms of x for both of these guys. So what I'm going to do is integrate in the y direction first. And what this is going to do, whoops, so what this is going to do, what's that little pink thing there? I think that's just an artifact of, yeah, that's just a, okay. So what I'm going to do is I'm going to take this guy and integrate from the bottom of the shape to the top of the shape like that. So this guy, I'm going to imagine integrating from there to there. Okay. So the way I'm going to set up my integral, and I could do any of these. So let's try and do like this one right here. Copy this guy. Come down here. So I need to start thinking about what I'm going to do for my integral. I'm going to split this up into dy times dx, which means I need a second integral here, like that. So we're just going to integrate dA, 1 times dA, in both the x and y directions. We're integrating first in the y direction because I have y in terms of x for both of these curves right here. So the furthest down I can go here is this thing right here. So I'm going to have to turn my first limit down here be this lower y2 thing. So this is going to be 1/2 of x minus pi. And the upper limit is going to be this upper curve here, which is sine x, like that. And now what I need to do is take this guy right here and sweep all the way from the left to the right. So I'm going to go from 0, which is as far left as this shape goes, to pi, like that. And that's how you set that up. If I want to do a different integral, I could do this qx guy, or let's just do let's do this right here. Copy this guy, paste it down here. And all I'm going to do here is for each of those integrals, I'm just going to copy that and paste it in each spot. The top one has to be the integral of x dA, so I'm going to change that 1 to an x, and dA on the bottom, so that's just that right there, 1 dA right there. If I want to do y bar instead, then I just change that to y. So it's the integral of y squared dA over the integral of dA. If I want to do q of I of x, so here's I about the x-axis, that's just going to be equal to, again, just copy this, paste it there, and put we're doing about the x-axis, so that's y, the distance y, so that's y squared dA. See, this Ix is y squared dA. And the last one is this Iy thing. And the only difference there is Iy is the integral of x squared dA. And there we are. I've set up everything. Here's the area. Here's the centroid, about the distance from the y-axis to the centroid, right? This is the distance from the x-axis, that's here, to the centroid. And this is the moment of inertia about the x-axis and the moment of inertia about the y-axis for that shape. So the reason I do double integration is because all of these things have exactly the same limits. See, these right here is the same as this here. It's the same as this here. It's the same as this here. The only thing that's different is if I want to do the area, I put a 1 there. If I want to do the integral of x dA, then I put an x there. If I want to do the integral of y dA, then I put a y there. If I want to do the integral of y squared dA, then I put a y squared there. If I want to do the integral of x squared dA, I put an x squared there. But other than that, they're all the same. So let's just take some random one. Let's do, for instance, this one right here, and see how you would actually go through the calculus, right? So to do this, if I'm integrating the y direction first, that means I'm taking this guy right here, and I'm integrating from the bottom to the top. Notice that in that entire range and integrating in the y direction, the x doesn't change at all. So what that means is, well, if I'm integrating in the y direction, I can treat x as a constant, and all I do is integrate y. I don't have any x's here. That's okay. So I'll just integrate y squared. That would be give me a y cubed over 3. So I can replace this entire integral here with y cubed over 3, and I'm just going to factor the 1/3 out. But I do have to evaluate this thing between the limits here, right? So this is going to be 1/2 of, oh man, did I forget a parentheses there? I did. On every single one of them. So I'm going to integrate it from there to the top, which is just sine x, like that. So I've replaced this entire integral right here with y cubed over 3, but I still have to evaluate it between those two limits right there. Okay, so let's do that. So this is going to be the top limit. So I'm going to replace the y with that top limit, and then cube it, and then subtract off this bottom limit and cube it. and close my parentheses. So all I've done is taken sine cubed x minus this garbage cubed, right? And now things are going to get funky, so you're going to have to be able to do calculus for the next step. So for instance, I'd probably want to FOIL that thing out. So there you go. So I'm going to copy this and put it up here. And I should put it in parentheses there. Like that. Standard notation for math, really you should take the that's how you typically write it if you're writing it on paper. Okay, so now I need to be able to integrate sine cubed and then that polynomial. I'm going to switch signs everywhere, so that's a plus sign, that's a plus sign, this is now a minus sign, this is a plus sign, and this is a minus sign. I just took the negative inside there. So now I've got to be able to integrate that. So I still have my third out there. Integral of sine cubed, I can't remember. Sine x cubed dx is that. Okay. Plus, oh, by the way, what I'm really doing here is getting rid of all of this stuff. So I'm integrating sine cubed, I get this, right? Plus, now I'm going to start integrating this. So this is x cubed over 8. The integral of that is going to be, oh no, that's pi cubed over 8. So the integral of that is going to be pi cubed over 8 times x, because we're just integrating that constant with respect to x. And then I got minus 3 pi squared over 8 times x squared over 2 plus 3 pi over 8 times x cubed over 3. So I integrated this and I got that. I integrated this, I get that. Integrated this, I get that. I just integrated that and I get this. And then we're going to get minus x raised, whoops, raised to the 4. Oh, I do my 1/8 first. 1 divided by 8 times x to the 4th divided by 4, like that. And that's the last term. I still have to evaluate that between 0 and pi, like that. This is why you do things on the computer, so you don't have to do your calculus by hand. Okay, sticking those limits in. Copy, paste. Hey, what's going on here? Okay, if I stick in pi here, cosine of pi is 1. So it's just going to give me a minus 3/4 plus cosine of 3 pi is actually, actually cosine of pi is -1, right? So that gets rid of that minus sign right there. Cosine of 3 pi is also -1, so this is turning that into a minus sign. We've got our 1/12 there. Plus pi, so this is going to be pi to the 4th over 8. Pi raised to the 4th divided by 8. Minus, again, pi 4th. So it'll be 3/16 pi 4th. So pi raised to the 4th times 3/16. And another pi 4th. They're all going to be pi 4ths, right? Pi to the 4th. So this is going to be, the 3's cancel out, so it'll just be pi over 8. This is plus pi raised to the 4th divided by 8. And then minus pi to the 4th over 8 times 4, which is 32, right? So pi raised to the 4th divided by 32. So it's going to be all of that stuff. I'm going to put another set of parentheses here. Minus if I stick in 0 for all of that. So if I stick in a 0 here, cosine of 0 is 1. So I'm going to get minus 3/4 inside my parentheses, minus 3/4. Cosine of 0 is again 1. So that's going to be 1/12. If I stick a 0 in any of those guys, yeah, if I stick a 0 into any of those guys, they all contain x's, right? So those all just drop out. And now you can plug that into your calculator and see what you get. Just to make sure we did this right, let's do it on the computer and see what happens. So I'm integrating from, again, this is what I'm doing right here, right? So I'm integrating from 0 to pi and from 1/2 of x minus pi to sine of x of y squared dy dx. Yep. Kind of a hard one, but that illustrates the principle. If I want to do the next one, if I wanted to do I instead of ix, then all I would do is take this and put an x there instead, and that's what that is. If I want to do the centroid, then I would do this divided by this, but replacing that with just a 1. So that's going to be qy divided by the area. That's what this is right here. Qy divided by the area right there. If I want to do y bar, I would change that to a y instead. It's a little bit negative, which means it's a little bit below the axis. Maybe I haven't drawn my things to scale there. Yeah. If you're doing this on the computer, it's a piece of cake. If you're doing it by hand, it's not too bad, but you do need to be able to do your integrals. So double integration to find all of this garbage.